Venn diagrams, and the greatest common factor and least common multiple. The learning goal for this lesson says that I can use a Venn diagram to find the greatest common factor and the least common multiple of two numbers. We're going to start with a brief introduction to Venn diagrams in case you're not already familiar with them. A Venn diagram uses overlapping circles to show the relationship between two or more sets of data. They're typically helpful when two or more sets of data have data points that are in more than one set. Let's look at a diagram. It'll become a little more clear. Suppose we're doing a study in our class of hair and eye color. We know that there are 25 people in the class. 15 people we've determined have brown hair, 5 people have blue eyes, and when we look a little closer, we see that 2 people have brown hair and blue eyes. So let's look at how that maps into the Venn diagram. I'm going to start with this number here, the 2 people that have brown hair and blue eyes. If we look at the Venn diagram, we see that the two circles overlap. And where they overlap, one circle is brown hair, one circle is blue eyes, so where they overlap is the 2 in the middle who have both the brown hair and the blue eyes. The next piece of data we've got says that there are 5 people that have blue eyes in total. So we've already accounted here for 2 people that have blue eyes. So the next step then is to say, well, 5 minus those 2 means that there are 3 more people that have blue eyes. Those 3 people don't have brown hair. Otherwise, they'd be in the overlapping area with them. So we've accounted for those 5 people that have blue eyes. Now let's look at the 15 people that have brown hair. In the same way we calculated the number of remaining people with blue eyes, we can say that we've got 15 people in total with brown hair, but we've already accounted for 2 of them here. So we're going to subtract those 2 from the total and say that there are 13 people who have brown hair but don't have blue eyes. Final piece of data that we've got says that there are 25 people in total in the class. So far, we've accounted for 13 plus 2 is 15 plus 3 is 18 people. If there are 25 people in total, that means that there are 7 that haven't been accounted for. So those 7 people don't have brown hair or blue eyes, so they're not in any of the circles, so we just include them inside the box of the Venn diagram. Now let's look at how the Venn diagram can help us when we're identifying the greatest common factor and the lowest common multiple. Focusing first just on the greatest common factor. The first approach we're going to do is to find all the factors of 30 and 40. So starting with 30, first of all, the set I'm going to be dealing with there, so I know that I can do 1 and 30, and I can do 2 and 15, and I can do 3 and 10, and I can do 5 and 6. So that's my full set of all the factors of 30. Now looking at 40, use a similar approach. I've got a 1 and a 40. I've got 2 and 20. I've got, now 40 is not divisible by 3, but it is divisible by 4. So I'll do 4 and 10. And then 5 and 8. Now I've got all the factors of 40. So in the same way that I arrange the people by eye color and hair color, this time I'm just going to look for whatever numbers or whatever factors are common to both 30 and 40. So I look here, I've got a 1 and a 1. So that means 1 is in the area of the overlapping circles. Then I've also again got a 2, so I can put a 2 in the overlapping circles. The 3 doesn't overlap, there aren't 2 of those, but there are 5s in both. So I can put a 5 in the overlapping circles. And then I also see I've got a 10 in overlapping. And if I was now going to go and put all the rest of the numbers in, I could see that 30, I want to account for the 3 because it's in a factor of 30, but it's not in a factor of 40. In the factor of 40, I'm going to put in a 4. The 6 goes in here. The 15 goes in as a factor of 30. And of course 30 goes in as a factor of 30. Finishing off the factors of 40, I've got an 8 there, so put it in. I've got a 20, and of course the 40. So you can see now from this, I've got These are all of the common factors. And the greatest common factor, or the largest one, is 10. So the Venn diagram just helps us to organize the data a little bit after we've done this process of finding all of the factors. However, the Venn diagram is much more useful when we're working with prime factors. Let's see how that works. So this time we're going to do prime factorization of the two numbers. So 30, we can do 3 and 10. Then we can do 2 and 5. We're down to prime factors there. 2, 3, and 5 are all prime. So now looking at 40, we can do 2 and 20, which is 2 and 10. Factoring the 10, we can do 2 and 5. So if we look now, we collect all of the prime factors for each one. We've got 30 is 2, 3, and 5. And for 40, it's 2 times 2 times 2 times 5. We could have also written that as 2 cubed times 5, but for the moment, we'll just work with the factors as they are here. Now, what I'm looking for are the common factors in the primes. So in this case, there's a 2 in each one. So I'm going to go ahead and take those 2's and put them in the overlapping area. There's no 3 over here, so I'm going to ignore the 3. But the 5 is common to both. So it will also go in the overlap. So I've accounted for the 2's, I've accounted for the 5's. I've got 1 3 left over in the factors of 30. And I've got 2 2's left over in the factors of 40. So let's just look at this quickly. If I'm looking at the factors of 30, I said that it's 2, 3, and 5. And you can see here within the circle is a 2, 3, and a 5. For the factors of 40, I said that there was a 2, 2, 2, and a 5. And if we look here in the circle that indicates the factors of 40, we've got 2, 2, 2, and 5. So the Venn diagram is representing our situation with the prime factors. Now, the cool thing about this is that the two numbers in the middle, if you multiply them together, that gets 10, which is, of course, the greatest common factor. Least common multiple. The least common multiple, or LCM, is the smallest possible integer that is evenly divisible by two given numbers. So for 5 and 6, the least common multiple is 30. So what that means is that if you take the number 30, you can divide it by 5, of course, and get 6. And you can divide 30 by 6, and of course you'll get 5. The question, though, is there a number that's smaller than 30 that can be divided by both 5 and 6? Well, let's say, well, what about 25? Is that divisible by both 5 and 6? Well, of course it's divisible by 5, but it's not divisible by 6. Okay, so we know it's not 25. What about 20? Well, 20 is divisible by 5, but 20 is also not divisible by 6. So if we keep going, there's no number we can think of that is smaller than 30 that can be divided by both 5 and 6. So 30 is definitely the LCM. Now let's look at 18 and 30. If we look at what we did with 5 and 6, we can see that multiplying 5 times 6 gave us the lowest common multiple. So let's see what happens if we do that here with 18 and 30. So if we're going to multiply 18 times 30, 30 times 8 is 240, 30 times 10 is 300. Adding those together, we get 540. So is 540 the lowest common multiple? Let's see if the Venn diagrams can help us to solve the problem. Let's use the prime factor method. So 18 is 3 times 6. 6 can be factored into 2 times 3. 30 can be 3 times 10. 10 is 2 times 5. So we've got the factors 2, 3, and 3 for 18, and 2, 3, and 5 for 30. Which ones are common? We can see in both cases we've got a 2 and a 2, and a 3 and a 3. So we can put the 2 and the 3 in the common area. That leaves us with the 3 as one of the remaining factors of 18, and the 5 as the remaining factor of 30. As we said in the previous example, 2 times 3 gives us the greatest common factor, and if we want the lowest common multiple, all we have to do now is multiply all of these numbers together. 3 times 3 times 2 times 5, 9 times 2 is 18 times 5 is 90. So 90 is certainly a much smaller number than the 540 we started out with. Let's take a look and see if that actually holds true. We can go back and test by taking the 90 and dividing it by 18. 90 divided by 18 will be 5. So that's giving us an even number. That's good. How about 90 divided by 3? Fairly simple. That's 30. So again, we end up with an even result. So this gives us the confidence to say, in fact, it is correct that 90 is the lowest common multiple. Let's do one more example. 36 and 48. Using the prime factor method again, I recognize that 36 is 3 times 12. I can factor the 12 into 3 times 4, and the 4 can be factored out further to 2 times 2. The 48, I'm going to do that as 2 times 24 to start off with. 24 is 2 times 12. The 12 is 3 times 4, and the 4 is 2 times 2. So I've got all my factors now. Factors of 36 are 2 times 2 times 3 times 3. And the factors of 48 are 2 times 2 times 2 times 2 times 3. Now let's go ahead and work them into our Venn diagram. So there's a 2 and there's a 2. I can put those in. There's another 2 in both of them that are common, putting those in. Now I'm out of 2's, but I can see I've got a 3 and a 3. I can put those in. That leaves me with 1 3 left over here, so that's going to go there. And 2 2's that are going to go in the factors of 48. Multiplying everything in the center, that's going to give me my greatest common factor, which is 12. And if I multiply everything together, the lowest common multiple is going to be 3 times 2 times 2 times 3 times 2 times 2. And when we multiply all of that together, we end up with 144. If we wanted to do the same check again, we would take 144, divide it by 36, and we can see that that would be equal to 4. If we take 144 and divide it by 48, we see that that is equal to 3. So we're getting whole numbers out the other side. So we have confirmed then that 144 is divisible by both 36 and 48. That number turns out to be much smaller than if we had just multiplied 36 and 48.
Because if we multiplied those together, we'd get 1728.
So we can find the greatest common factor and least common multiples by first doing prime factorization, then second, putting all the factors into a Venn diagram, then multiplying the common factors to get the greatest common factor. And then fourth, we can multiply all the prime factors in the Venn diagram to get the least common multiple.